Hello guys, good to see you here. In Chapter 4, we will be studying one of my favorite subjects, histology. Histology is the study of the tissues that make up our body. There are 4 tissue types in the body: the epithelium, connective tissue, muscle, and nerve. You'll be asked to know some basic information about these tissues, including the types of cells that make it up, their functions, and where they are located in the body. We will also be learning more about the membranes of the body, and we will begin to learn the basics of tissue repair. So let us now begin our study with the epithelium. In the embryo, epithelium is derived from all 3 germ layers: the ectoderm, the mesoderm, and the endoderm. The epithelium forms the coverings and the linings on both the outside and inside of the body, and forms glandular tissue. There are 3 shapes of epithelial cells: squamous, cuboidal, and columnar. Squamous cells are flat and scale-like. They are very thin, which allows substances to move quickly through them and to form the thin membranous linings. They are also good for stacking. In areas of the body where there's a lot of abrasion, squamous cells are stacked in layers and divide rapidly, replacing the upper layers often. Cuboidal cells are much like their name implies. They are cuboidal in shape and are usually found in the ducts of glands and the kidney tubules. These cells are designed for secretion and absorption. Columnar cells are similar to cuboidal, but they are taller than they are wide. These cells are designed for absorption and the secretion of mucus. A specialized type of columnar cell, which is ciliated, moves substances across the cell surface. Epithelium may be simple, which is 1 cell thick, as in this slide of the alveoli of the lung showing simple squamous, or this one of the kidney showing simple cuboidal cells. Epithelium that is stacked is called stratified. Stratified epithelium is found in the upper and lower part of the digestive system and in the skin, which has a specialized kind of stratified epithelium. When discussing epithelium, we will refer to the upper free surface, which is exposed to the body exterior or the cavity of a hollow organ, as the apical surface, and the lower part of the epithelium that is attached to another tissue as the basal surface. We can also use these terms when referring to a single cell. Here is the apical surface of the cell and the basal surface. Now your textbook and lab manual have the same figures in regard to tissue slides. Please know all of these figures from your textbook and lab manual. When we meet for lab, you'll be looking at the actual slide preparations under the microscope. Here are the ones in relationship to epithelium. The glands of the body are derived from epithelium. There are 2 types of glands: endocrine and exocrine. Endocrine glands are ductless glands and secrete their products directly into the bloodstream. Examples are the portion of the pancreas that secretes insulin and the adrenals. Exocrine glands, on the other hand, secrete their products through ducts. Examples are the sweat glands of the skin and the salivary glands. The pancreas is also an exocrine gland, secreting digestive enzymes into the small intestine. So the pancreas is both an exocrine and an endocrine gland. Let us now move on to connective tissues. There are 4 main classes of connective tissue. There's connective tissue proper, cartilage, bone, and blood. The connective tissues of the body serve to bind and support tissues to each other, protect us through the immune system, insulates the body, is storage of reserve fuel as fat, and transport of substances through the blood. In the embryo, connective tissue arises from the embryonic tissue called mesenchyme, which is derived predominantly from the middle germ layer called the mesoderm. All connective tissues contain three common elements: the cells that produce the substance of the connective tissue, the fibers that give the structure and support to the connective tissue, and the liquid substance called ground substance. Sometimes the fibers and the ground substance together are referred to as the extracellular matrix. The cells of connective tissue are the immature blast cell and the mature site. The blast cell secretes the matrix of the CT, and once the matrix is synthesized, the cells become a site. During times of trauma, the site can revert back to a blast. Think of the blast cell as the young 30-something-year-old construction worker who goes into retirement once he has built all the houses in his zone. He then becomes a property manager unless one of the houses burns down, and then he comes out of retirement and rebuilds it. The specific name of the cell depends on the type of extracellular matrix it produces. In connective tissue proper, the extracellular matrix contains a lot of collagen fibers, so the cell is called a fibroblast. In cartilage, the cell is called a chondroblast because chondro relates to cartilage. And in bone, the cell is an osteoblast. Osteo refers to bone. Other cells found in CT are the fat cell, also known as adipocytes, and the cells of the immune system, white blood cells, macrophages, and mast cells. Now let's look at the different types of connective tissue. With connective tissue proper, we have two types, loose and dense. There are three types of loose connective tissue: areolar, adipose, and reticular. Dense connective tissue can be further divided into dense regular and dense irregular. Let's now take a look at the figures in your textbook of the slides of connective tissue proper. So those are the types of connective tissue proper. Please make sure that you know the figures and you know the information in them. Now moving on to cartilage, you will find that there are three types of cartilage: hyaline, elastic, and fibrocartilage. I will now show you the figures from the textbook, and again, make sure you know how to recognize those pictures and you know the information in them. We will study cartilage further when we study the skeleton. Bone will be studied in great detail when we study the skeleton. Please know the information on the figure in your textbook. And the same is true for blood when we study the cardiovascular system. Moving on to muscle now. There are three types of muscle tissue: skeletal, cardiac, and smooth. Skeletal and cardiac muscle will be covered in great detail when we get to their specific chapters. For our purposes in Chapter 4, I'd like you to know the three different cell types and what makes them different from each other. So here are the pictures from your text. And lastly, we have the nervous tissue. This picture in your textbook is showing neurons, which is the functional cell of the nervous system. We'll have other slides in class where you'll be looking at neurons. The last topic for this video is the membranes and the linings, which we began our discussion of in Chapter 1. Tissue repair will be covered in the next chapter, Chapter 5, with the integumentary system. So the three types of linings in the body are the cutaneous or skin, the mucosa, and the serosa. The serous membranes, also known as serosa, are moist membranes found in the closed ventral cavities, which we will study with their respective organ systems. It's a simple squamous epithelium resting on a loose connective tissue. The mucous membranes, also known as the mucosa, line all of the hollow organs that are open to the outside of the body. These are wet or moist membranes that we will see in the mucosa of the respiratory, digestive, and urogenital system. And we will study those in great detail when we study those organ systems. So that concludes the information from Chapter 4, Histology. And this video and the slides we look at in lab in association with Exercise 5 and what we do in lecture will be the required material for this section. So don't overstudy.